In private lessons, I often mention natural numbers, real numbers, or rational numbers. In this lesson, we will learn about those sets. Lesson 4, number sets. Firstly, we review of number sets which we have already learned in earlier grades. The exercise: draw a diagram to illustrate the inclusions of number sets you have learned. Okay, together we will show this exercise at the end of this lesson. The first number set is the set of natural numbers, which is denoted by the letter N, but it is not a simple capital letter. It is especially letter with double middle lines. There are two kinds of natural numbers. The first, the set of natural numbers with 0 include 0, 1, 2, 3, etc. and go to positive infinity. The second, capital letter N with asterisk like this, and it contains 1, 2, 3, etc. and go to positive infinity. We can display natural number and other kinds of numbers on a number line. Every point on number lines represents a number. So you can see the sets of natural numbers begin from 0 to infinity, and every point of lines is a numbers. You can see there are two kinds of natural number. Natural number from 1 to positive infinity, and the whole numbers from 0 to positive infinity, and this is the end with asterisk, and this is the end set. The second number set is the set of integers. It is bigger than the set of natural number and include number from negative infinity to positive infinity, and denoted by Z, a capital letter with double middle line. You can see Z include negative number like -2, -1, and zeros, 1, 2, etc. and go to positive infinity. You can see this is integers number lines. It includes negative numbers and positive numbers, but 0 is neither positive nor negative. The set of rational number is denoted by letter Q. You see, a rational number is represented in a form of a fractions A over P, where A, P are elements of integers number, and B is not equal to 0. Two fractions A over B and C over D represent the same rational number if and only if A times D equal B times C. From that, we infer all integers can be written in a form of rational number with denominator E equal to 1 and numerator E dash number, as I said in a certain video. For example, integers 2, equal 2 over 1, or integer 3 equal 3 over 1. It entails sets of rational number is bigger than the sets of integers, and rational number can take a form of a finite decimal or an infinite repeating decimal. For example, 5 over 4 equal 1.25, or 5 over 12 equal 0.41, and digits in parentheses. This is the number lines of rational number. Q, you can see is go from negative infinity to positive infinity. It includes natural numbers, integer number, and fractions. The 4 sets of numbers we will learn in this lesson is the set of real numbers, is denoted by the capital letter R, like this. The set of real number contains finite decimals or infinite repeating decimal and infinite non-repeating decimals. Infinite non-repeating decimals are called irrational number. It seems quite difficult to distinguish those kinds of number, so I give example to help you understand more. Firstly, finite decimal. For example, 1.2 or 4.578. Decimal are numbers behind dot size. So, in number 1.2, 2 is decimal, and 578 is decimal of this number. Infinite repeating decimal. For example, you see 5 over 3 equal 1.6666, a lot of digit 6. We see the digit 6 is repeated, so we can write 0.6 with a bar over the digit 6, or 0.6 digits in parentheses. Like example in the book, you see the 6 in the parentheses. So this number is repeating. Your calculator often displays this form when the result is an infinite repeating decimal. You can try to see it. Okay. Another example, 1 over 27 equal 0.0737 037. 3 digits 037 are repeating, so we can write them in form 0.037 with a bar over 3 digits, or equal 0. Parenthesis 0.37. That means 3 digits are repeating. And infinite non-repeating decimal. For example, square root up to equal 1.4145. etc. Its decimal are non-stop and non-repeating, or pi is a popular number with million digits after the dot sign. From that, we infer the set of real numbers is bigger than the set of rational numbers. And this is number lines of real number. So you can see it goes from negative infinity to positive infinity. It includes natural numbers, integers, rational number, and irrational numbers. To review all number sets, we see the diagrams that show all number sets. Firstly, natural numbers include, for example, 1, 2, 3. The whole number include natural numbers and 0. The integers numbers contains the whole number and negative number. The rational number contains integers and rational numbers like 1/2, infinite repeating decimal, and real number include rational number Q and irrational numbers like pi or square root of tens or 7 point with a lot of number behind the dot sign.